Solutions. And sadly, solutions in chemistry do not mean solutions to our problems. Wouldn't that be nice? A solution is a homogeneous mixture. I'm skipping section 13.1. It's interesting. There's a lake in Africa there's some sort of volcanic action underneath, and carbon dioxide comes up into it, and periodically the concentration builds up, and the lake essentially burps. And the last time it did that, it killed 1,700 people.
Wow.
Because this big cloud of carbon dioxide comes up and suffocates everything. It's really crazy.
Wait,
so you might want to read that
it
section.
burps out of it gathering in solution, or it burps out of the ground gathering up?
The water gathers up the carbon dioxide in
it's
solution.
So it's like super.
It's super saturated, yeah.
Well,
So you'll have to read about it, because I'm not going to talk about it anymore. But a solution is a homogeneous mixture. So a solution has two or more substances in it, and solutions are very, very common. So the ocean. The ocean is a solution. Water is the solvent, and then it's got lots of stuff dissolved in it. The blood flowing through your veins is a solution. Okay, you've got blood plasma is what you've got left when you take the blood cells out. And the blood plasma has a variety of solids, as well as some gases that are dissolved in water. And so those are considered solutions. So we typically think of a solution as being a solid dissolved in a liquid, or maybe a liquid dissolved in a liquid. But solutions can exist between any states. You can have solutions of two solids or two gases or all kinds of combinations. So here are some examples. Air is an example of a solution of gases. So it's mostly oxygen and nitrogen with other gases, and they're all mixed together. So soda water is a mixture of a gas in a liquid. It's got carbon dioxide dissolved in water. Alcoholic beverages are solutions of ethanol in water, varying concentrations. Seawater is a solid dissolved in a liquid. And you might say, well, how can you make a solution of two solids? How does that work? Well, do you know what an alloy is? Brass, 24-karat gold, stainless steel, regular steel. We have a lot of metals, what we think of, well, that's made out of metal. It's actually an alloy, it's not a pure element. It's a solution of two or more metals dissolved in each other. Of course, you don't do that by just smashing two metals together, you have to heat them up. But what you end up with is a solution of two solids. So solutions have at least two components. There's the solvent and the solute, and we need to be able to identify which is which. The simplest way is we say generally the solvent is the one that there's more of. Okay? A lot of times that ends up being a liquid. But what if you have two liquids? Well, it depends on which one you have more of. Do you have ethanol with a little bit of water in it? Then the ethanol is the solvent. Or do you have water with a little bit of ethanol? Yes?
When you say more, do you mean like more in moles or more in grams?
Usually it'll be both. It's, in a solution, you could use either one most likely and come out correct. Because usually the solvent, there's a lot more of it. It's not like bordering on half and half. So the solvent is what there's more of, and the solute is what there's less of. If you have a solid liquid solution, the liquid is usually considered the solvent, and it is usually the one that's present in greater amount, but not always. Water is considered the universal solvent, and we've learned this word before, aqueous. Aqueous means a solution in which the solvent is water. There are other solvents that are used in industry, in the lab, in your house perhaps. And when we think of the word solvent, I tend to think more of like paint thinner, right? some organic compound that dissolves stuff. And so those substances are also solvents, but the most common one is water. So I have my, knockoff Mio here. And the solvent is water. And then there's like purple, which is red and blue food coloring in there, and there's caffeine, there's a little bit of flavor. But the solvent is water. There's not enough caffeine, I need more. So our study of intermolecular forces will help us to understand how solutions are made, and why we have different kinds of solvents. And so we have this general principle, like dissolves like. So if the solvent and the solute have similar types of intermolecular forces, they will dissolve. You will form a solution. If their types of forces are different, then you will not form a solution. So we see that polar solvents will dissolve polar solutes, and nonpolar solvents will dissolve nonpolar solutes. So remind me this afternoon to show you the YouTube solvent music video. It's kind of amusing. It has bears in it. It's funny. I think it's funny. So here are some common solvents. Polar solvents include water, acetone, methyl alcohol or methanol. Nonpolar solvents are things like hexane, diethyl ether, toluene. These tend to be hydrocarbons, meaning they're mostly carbon and hydrogen. And so there's just really no polarity going on. This diethyl ether, you might say, well, there's an oxygen in the middle. Yeah, there's a little bit of polarity from that, but then you've got these two carbons surrounded with hydrogens on each end of it, and so it ends up being symmetrical, pretty symmetrical and nonpolar. Bless you.